Hello guys and welcome. In this lecture we will talk about morphological operations or transformations, which are some simple operations based on the image shape. These type of operations are usually performed on binary images. So let's start. First I will create a Python file. I will name it morphological operations.py, and then I will start by importing CV2 and numpy. And then I will create an image here, so I will call it image. I will create it from numpy, create a black image, zeros with width and height of 400 and 400, and data type of np.uint8. I will put some text on this black image, so I will use cv2.putText on this image. I will put on it OpenCV, and the origin of this text will be at the position of, let's say, 10 for example, and 220. And I will use cv2.fonts Hershey complex and the font scale as 2, and I will use the white color, so I just need to put 255, and the thickness as 5. Let's show this image, cv2.imshow original image, and call it here, and then cv2.weight 0. Let's run this code, Python morphological operations, and then as you can see the text here, we can make this for example 3 to have text, bigger text. So now we have this text on this white text on this black image. The first operation that we will see here is called the erosion. So erosion, it is, let's call the resulted image as erosion, and we will call cv2.erode. This will take this image and a kernel, so I need to create here a kernel as np.once with size or shape of 5 and 5. We can modify this later by saying 3 3 or 7 7. We must use an odd number, and the data type as np.uint8. so we need to give it the kernel and the number of iterations. I will just use the default one, which is 1. So now let's see the resulted image, cv2.imshow erosion, and call it here, and let's run the code. So as you can see, this is the resulted erosion image here, which is the result of this operation here, the erosion operation. Another operation called dilation. So this operation is just the opposite of erosion, so this will be delete the image with using this kernel, and the number of iterations will be also 1. We can modify this later and see how they change the image. So now cv2.imshow this dilation operation and call the resulted image. Now let's see it here. So this is the resulted image of dilation, and this of erosion, and this is the original image, as you can see. Let's change the kernel size here and see how it affects the resulted image. So if we use a bigger kernel size, so now you can see how it changed this one. If we make it also bigger, it will change how the result image looks like. So this is deletion. Now we have smoother image, and in the origin we lost everything here. We can also augment the number of iterations, so let me also see a smaller kernel size and see its results. So this is smaller kernel size. You can see that it's changed the image a little bit. But what if we augment the number of iterations? If I make them, for example, 2, so that it means that it made this operation 2 times, and of course it changes the origin than the first one. If I, for example, use a 5 and 5 kernel size, you can see here that it's of course changes the origin, and we can't read this text in the with the origin operation. There are another type of morphological operations which are called opening and closing. So let's see the opening. This operation is just origin followed by dilation, while the closing is the opposite. This is dilation followed by origin. So let's see each one. Opening is, I will call the result image opening cv2.morphological.ex and use the image, and then give it cv2.morph.open, and then give it the kernel size or the kernel, and you can also specify the number of iterations. I will use the default one, which is 1, and use it also for closing. So the closing image is cv2.morphological.ex image and cv2.morph close. Let's show this resulted image, cv2.imshow. First one is opening, this opening, and the second one is imshow. This is closing, and let's call it here closing. Let's run the code and see. So this we didn't give it kernel here, and now we are ready to run the code. So this is the closing and this is the opening, and you can see here the deletion and the origin that we have seen before. So this opening is just when we do origin and followed by deletion, but here because we did here 2 iterations, so we can see because the default one here is 1. So if I run the code from here, so the deletion, the origin, so now the opening is just doing the origin and then doing the deletion on this image, and the closing is the opposite, start by deletion and then doing origin to get this image. There are another type of morphological operations like the gradient, and this is just the difference between origin and deletion. So this, if I call the image gradient and cv2.morphological of that image using cv2.morph gradient and give it the kernel and show the image here, come here cv2.imshow, this is gradient, and call the image gradient. Let's run the code and see. So this is the gradient operation, and this is the images that we have seen before: opening, closing, and deletion, and origin, and the original image. Another type of morphological operation is top hat. So this is just the difference between the original image and its opening. So if I call it here Tophat and call cv2 dot morphological of that image using cv2 dot morph Tophat and using the same kernel, and if I show it here cv2 dot imshow Tophat and call the image here, and if I run the code, you can see here that we lost everything. If I change the kernel here, for example saying kernel of 9 and 9 and see it here, so now we can see the image because the difference now is bigger. And another type also of morphological operation is which is called Blackhat, and this is the difference between the image, or the difference between the closing of this image and the image itself. So if I call it Blackhat and call cv2.morphological of that image using cv2.morph Blackhat and using the kernel, and then if I come here and saying cv2.imshow now Blackhat and call the image here Blackhat, so as you can see this is the Blackhat of the image, and this is Tophat, and these are the gradient, closing, opening, because now we are using a bigger kernel, so the origin is we can't read it. We can also try it with another image. So if I comment this and read an image from data, image equals to cv2.imread of I will read an image in the data called G, and if I run the code you can see it here. So this is a very small image. This is the gradient, this is the closing, the opening, dilation, erosion, and the original image. Let me change this kernel to have it, for example, 5 and 5. So now you can see the Blackhats and the gradient here, the closing, the opening, dilation, and the origin here. Now it is visible and we can read it, and this is the original image, as you can see.